Okay, a midsegment is parallel to one side of the triangle. So notice the arrows indicating that those two segments are parallel. And a midsegment connects the midpoint of one side to the midpoint of the other side. So notice with the tick marks, point J is the midpoint of FH, and K is the midpoint of HG. So a midsegment connects the midpoint of one side to the midpoint of the other. It's going to be parallel to like the base of that triangle, and the rule is that the length of the midsegment is half of the length of the side. It's like 1/2 the length of that side. So JK is half of FG. So if you know the length of JK, you would double it to get the length of FG. If you know the length of FG, you're going to divide it by 2 to get the length of JK. So in this example, XY is a midsegment. So if XY is 7, then to get the length of the side, ST, I'm going to double the length of the midsegment. So XY is 7, so that means that ST is 14. And if these are midsegments, then that means that Z is a midpoint, so SZ would be 7, and ZT would also be 7, just FYI. So ST is 14. Then we know that this whole side is 13, so I know that the midsegment is going to be half of that side that it's parallel to. So 13 divided by 2 is 6.5. So XZ is 6.5, and RY is 6.5, and YT is 6.5, since Y is the midpoint of RT. Okay, then it also wants us to find the measure of angle XYR. So XZ is the midsegment, so it's going to be parallel to this side. So if I think of XY as my transversal, I have some alternate interior angles right here. Alternate interior angles. Blast from the past, haven't seen that in a long time. These are alternate interior angles, and when those lines are parallel, the alternate interior angles are congruent. So that means that this angle is 124. So the measure of angle XYR is 124 degrees, because these are congruent because they're alternate interior angles, because those sides are parallel, because it told us that XZ was the midsegment.